A first order reaction which is 60% complete in 30 minutes has a half-life period of a first order reaction. So the formula will be K is equal to 2.303 upon T log of A upon A minus X. So 0.693 upon T, which is equal to 2.303 upon T log of 100 upon 100 minus 30. Therefore, our time will be 58.2 minutes on solving this equation. So option B is the correct answer. In a first order reaction, A upon A minus X value was found to be 10 after 15 minutes. The rate constant for the reaction is A 0.153 per minute, B 0.135 per minute, C 0.315 per minute, D 0.351 per minute. So this is first order reaction. So K is equal to 2.303 upon T log of A upon A minus X. So we can write this as K is equal to 2.303 upon 15 log of 10, as A upon A minus X is 10. So on solving this we get 0.153 per minute. So option A is the correct answer. The following graph shows how T half of a reactant R changes with the initial reactant of concentration A0. The order of the reaction will be. So in this given reaction, T half is directly proportional to 1 upon A naught raised to n minus 1. So A naught raised to n minus 1 is equal to A0, which is given. Therefore n minus 1 is equal to 1. Therefore n is equal to 2, which is our order. So 2 is the order. Option C is the correct answer. If A is the initial concentration, n is the order of the reaction, a half-life period T is. The time period is given by 2.303 upon T log of A upon A minus X, where A is the initial concentration. On solving, we get T half is equal to 1 upon A raised to n minus 1. So option, we have to put here a constant sign as we equate it. So option D is the correct answer. In presence of HCl, sucrose get hydrolyzed into glucose and fructose. The concentration of sucrose was found to reduce from 0.4 mole to 0.2 mole in 1 hour and 0.1 mole in 2 hours. The order of the reaction is. As the concentration reduces from 0.4 mole to 0.2 mole, which is half quantity in 1 hour, and from 0.2 to 0.1, which is the half of this in next 1 hour, which is equal to 2 hours. So this is a reaction of T half where it is inversely proportional to concentration raised to n minus 1. So the order of the reaction will be 1. What is the half-life of carbon 14 if the disintegration constant is 2.13 into 10 raised to minus 4 per year? So T half is equal to 0.693 upon K, which is rate constant. So we can write 0.693 upon the rate constant is 2.31 into 10 raised to minus 4 equal to 0.3 into 10 raised to 4 years. So our T half is 0.3 into 10 raised to 4 years. Option C. The rate constant for a chemical reaction has units liter per mole per second. The order of the reaction will be. The unit of rate constant is equal to per time upon concentration raised n raised to minus 1, where n is the order. Therefore liter per mole per second is equal to per second upon mole per liter raised to n minus 1. So we can write this as s raised to minus 1 L mole per liter n minus 1. 1 is equal to n minus 1, where n is equal to 2. So option C is the correct answer. The half-life period of first order reaction is 10 minutes if the initial amount is 0.08 mole per liter and concentration at some instant is 0.001 mole per liter, then time t is, as the concentration from 0.08 mole per liter to 0.01 mole per liter, it changes. So there are 3 half-lives, from 0.08 to 0.04, then 0.02, and then 0.01. So t is equal to 30 minutes. So option B is the correct answer. So our next question is, the rate constant K1 and K2 for two different reactions are 10 raised to 6 dot e raised to minus 2007 and 10 raised to 5 dot e raised to minus 100 T respectively. The temperature at which K1 and K2 will be equal is, so we got 10 raised to 16 e raised to minus 2000 upon T equal to 10 raised to 15 e raised to minus 1000 upon T. So we can write this as 10 equal to e raised to minus 1000 upon T divided by e raised to minus 2000 divided by T. So 10 is equal to e raised to 1 upon T into 1000. So ln of 10 is equal to 1000 upon T. Therefore 2.303 log 10 is equal to 1000 upon T. On solving this, we get value of T as 1000 upon 2.303 K. So option B is the correct answer. For first order reaction, rate constant is 0.6932 per hour, then half-life period for the reaction is T half is equal to 0.693 upon K, where K is rate constant. So we can substitute the value of K as 0.693 per hour, which is given in the equation. So we get answer as 1 hour, which is our T half. So option B is the correct answer. The rate constant for a first order reaction is 3 into 10 raised to minus 6 per second. The initial concentration is 0.10 mole. The initial rate of the reaction is, so given is the rate constant of first order reaction, K is equal to 3 into 10 raised to minus 6 per second, and the initial concentration A is equal to 0.10 mole. We know that initial rate constant Ka is equal to 3 into 10 raised to minus 6 into 0.10, which is equal to 3 into 10 raised to minus 7 mole per second. So option D is the correct option. For first order reaction, A will give product. The rate of the reaction at A equal to 0.2 mole per liter is 1 into 10 raised to minus 2 mole per liter. The life period of the reaction is, so R is equal to K into reactant. Therefore K is equal to 1.0 into 10 raised to minus 2 upon 0.2, which is equal to 0.05. Therefore T half is equal to 0.693 upon 0.005, which is equal to 13.86 minute into T. Therefore 13.86 into 60, which is equal to 831.6 seconds. So option A is the most appropriate answer. For an elementary reaction, 2A plus B will give C plus D. The molecularity is, let us consider a reaction 2NO plus Cl2 will give 2NOCl. So for this reaction, the rate will be KNO2 Cl2 1. Therefore order of the reaction will be 2 plus 1. This 2 and 1 is equal to 3. So option D is the correct answer. The following mechanism has been proposed for the reaction of NO with Br2 to form NOBr. So NO gas plus Br2 gas will give NOBr2, where NOBr2 plus NO gas will give 2NOBr. NO gas is the different rate law of NO plus Br2 will give NOBr2 will be minus dC upon dt, which is equal to K NOBr2 with NO. We have Kc is equal to NOBr2 upon NO into Br2. Provided the reaction attains equilibrium rapidly, therefore minus dC upon dt is equal to K into Kc into NO raised to 2 and Br2, which is equal to a new constant K dash with NO raised to 2 and Br2. So the order of the reaction with respect to NO is 2, option D. So our next question is, hydrolysis of DDT is a first order reaction. Its half-life is 10 years. The time to hydrolyze 10 gram of DDT to half is. So we know that rate constant K is equal to 0.693 upon T half. We can write this as 0.693 upon 10. The initial concentration is 10 gram and the final concentration X is equal to A by 2, which is equal to 5 grams. Then T is equal to 2.303 upon K log of A upon A minus X. Substituting the values, we get 2.303 upon 0.693 into 10 into log of 10 upon 5. On solving this, we get T is equal to 10 years. So option D is the correct answer. Next question is, in first order reaction, the concentration of the reaction is reduced to 25% in 1 hour. The half-life period of the reaction is. So we know that K is equal to 2.303 upon 1 hour log of 100 upon 25. On solving this, we get log 4 is equal to 1 upon T of log 2. Therefore 2 log 2 is equal to 1 upon T of log 2. Therefore we can write this as T is equal to half year. So option C is the correct answer. Next question is, the half-life period of two samples are 0.1 and 0.4 seconds. Their respective concentrations are 200 and 50 respectively. What is the order of the reaction? So for this reaction, we can take formula T half is directly proportional to A raised to 1 minus N. So substituting the value, we get 0.1 upon 0.4 is equal to 200 raised to 1 minus N upon 50 raised to 1 minus N, which is equal to 1 upon 4 equal to 4 upon 1 raised to 1 minus N. We can write this as 1 upon 4 raised to N minus 1. Therefore N is equal to 2. Option B is the correct answer. So our next question is, for a first order reaction, the time taken to reduce the initial concentration by a factor of 1/4 is 20 minutes. The time required to reduce the initial concentration by a factor of 1 by 16 is, let 1 be the initial concentration. In the first degradation we get half, then the second we get 1/4, third we get 1/8, and in the fourth degradation we get 1/16 of the initial concentration. So 1/16 is 4 half-life and 1/4 is 2 half-life. It is given that the time taken for 2 half is 20 minutes. So the time taken for 4 half-lives is equal to 40 minutes. So option D is the correct answer. For a reaction, capital A will give XP when capital A is equal to 2.2 millimoles. The rate was found to be 2.4 millimole per second. On reducing the concentration of A to half, the rate changes to 0.6 millimole per second. The rate order of the reaction with respect to A is. So the given equation is A, capital A will give xp. So the rate of the reaction is capital A raised to small a. Order of the reaction is small a. A1 is equal to 2.2 millimoles. R1 will be 2.4 millimole per second. A2 is equal to 2.2 divided by 2, and R1 will change to 0.6 millimole or 2.4 upon 4. On reducing the concentration of A to half, the rate of the reaction is decreased by 4 times. Therefore, rate of the reaction is equal to A raised to 2. Therefore, order of the reaction is 2. So option B is the correct answer. The rate of the reaction between two reactant A and B decreases by a factor of 4. If the concentration of reaction B is doubled, the order of this reaction with respect to B is. We know that R is equal to KB raised to N. So we can write this as 1 by 4 R is equal to K 2B raised to N. 4 is equal to half raised to N. Therefore, 4 is equal to 2 minus N. Therefore, N is equal to minus 2. So option B is the correct answer. For a reaction, A plus B will give C plus D. If the concentration of A is doubled without altering the concentration of B, the rate gets doubled. If the concentration of B is increased by 9 without altering the concentration of A, the R is tripled. The order is. So given equation is A plus B will give C plus D. So rate is equal to K A raised to A or alpha and B raised to beta. 2R is equal to K 2A raised to alpha B raised to beta. This be equation 1. Equation 2. 3R is equal to K A raised to alpha and 9B raised to beta. This is our equation 3. Dividing equation 2 by equation 1, we get 2 raised to 2 alpha is equal to, or alpha is equal to 1. And now dividing equation 3 by equation 1, we get 3 equal to 9 beta or 3 equal to 3 raised to 2 beta. Therefore, beta is equal to half. Therefore, order of reaction is equal to 1 plus half, that is alpha plus beta is equal to 3 by 2. So option C is the correct answer. If A and T have initial concentration of the reaction of half-life of 0 order reaction respectively, which of the following is correct? General expressions of half-life if given as T half is inversely proportional to A raised to N minus 1, where N is the order. For 0 order reaction, N is equal to 0. Therefore, T half, which is inversely proportional to A raised to 0 minus 1, therefore T half is directly proportional to A. So option B is the correct answer. Which of the following is not correct of the equation? We know that T half is equal to 0.693 upon K, or N equal to N0 e raised to minus KT. We can write ln N upon N0, which is equal to minus KT. Therefore, KT is equal to ln upon N0 upon N. Therefore, 1 by N minus 1 upon N0 equal to ln KT half is not correct. So option C is inappropriate statement. Next question is decay of U2 raised to 35, which is atomic mass, and 92 be atomic number, is order reaction. So uranium 235 upon 92 is a radioactive element. The radioactive disintegration reaction is of first order because its rate is disintegration depends on concentration of the radioactive material only. So option B is the correct answer. A reaction is of the first order relative to A and is of second order relative to B. What will be? A, velocity remains constant, B 4 times, C 2 times, D 8 times. So we can write it as R is the rate constant, rate is equal to K into A, B raised to 2. So R dash is equal to K 2A into 2B raised to 2 equal to 8K into A into B raised to 2. Therefore R dash is equal to 8R. So become 8 times option D. So our next question is cyclopropane rearranges to form propene. This follows the first order kinetics. The rate constant is 2.714 into 10 raised to minus 3 per second. The initial concentration of cyclopropane is 0.29 moles after 10 second order is. So we know that K is equal to 2.303 upon T log of A upon A minus X, where A minus X is the concentration left after 100 seconds. So we know that 2.7 into 10 raised to minus 3 is equal to 2.303 upon 100 log of 0.29 upon A minus X. So after solving this, we get value of A minus X is equal to 0.22 moles, which is left over after 100 seconds. So option B is the correct answer. Next question is half-life of first order and zero order reaction are same. Then the ratio of initial rates of first order reaction to that of zero order reaction is. So we know that T half for zero order reaction is A0 upon 2K. T half for first order reaction is 0.693 upon K. Rate is equal to initial rate, which is A0 equal to 1. So 1 upon 2K is equal to 0.693 upon K dash. Therefore K dash upon K is equal to 2 into 0.693. So option B is the correct answer.